Okay, so guys, I just created this new account, and there's one weekday morning batch going on right now. So I made them also create a new account. So there were some new findings, you know, we had, some interesting findings which I wanted to share with you all as well. So see, now when you create a new account, now those default databases that used to come here, right? So since you guys have the old account created, so you are still seeing that demo DB and util DB, which were the default databases that Snowflake used to provide, right? When you create the account. So see, now they have stopped doing that. They don't provide those empty default databases. The shares are already there. The Snowflake share and this Snowflake sample data share is there anyway. It's still there. And one more thing, the change I saw is if you go to the roles here, so here they have now started to assign org admin also. Okay, so when this batch had started and we had created our accounts, that time org admin was visible under the accounts ribbon item here. When we used to go to accounts and look at roles, we used to find org admin here, but it was not assigned to our user, right? So now also it is not assigned to you guys, but now they have default given the org admin role as well to the user. So once your account expires and you recreate the account, you will see these changes. Or if you want to switch to a new account, you can use a new email ID. Guys, am I sharing my screen? You are able to see, right?
Yes, Sardar.
Okay. Or if you want to still, switch to the new account, you can use a new email ID. Up to you. Okay. So these are some changes that has come in the latest account creation that I also I was telling my new weekday students that you will see only 5 roles here, and they said okay, we are able to see 6 and there's org admin. So then I got them to share the screen, and I was also surprised that they have changed, the Snowflake has changed all these settings. So yeah, I just wanted to share this with you. And if you remember, we had this hierarchy, right? That at the very top of the Snowflake container hierarchy, we have organization. Let me just quickly go back to that slide. Yeah, this one. So if you remember, organization is at the top, and then you have account, and then you have various other objects under them. So at under the organization, you can create multiple accounts, right? So org admin, so as I had told you, org admin is the role that allows you to create multiple accounts. So if you switch this role, right, org admin, there'll be a new ribbon item called organization visible to you here. Okay. And if you click here, so this is the existing account that is which I've logged in with. So this is my account locator, right? This part, the first part of the string in the URL is my account locator, and this is my other account details. Okay. So I can create one more account here in the same organization. So what is my organization here? If I click here, so this is my organization, NOQQCWW, and this is my account locator URL. This is my account URL. Okay, see NOQCCW, and here also this one. So if I want to create one more account under the organization, I can do it using the org admin role. Okay, so this ribbon item will be visible to us. Here I can go create a new account, and all these options are the same when we create the account first time, if you remember, right? We have to choose the cloud, we have to choose the region, we have to choose the edition, and next. Right? So I just wanted to share this information with you. So any doubts in this? Quite pretty straightforward, right? Cool. So all that time, we were talking theoretically about the org admin because, as you know, that we cannot have org admin role in the past. We have to contact Snowflake support to assign it to us. Okay, and then in return, they will ask you so many other questions like which organization do you belong, which company you are working for, and all that. So to not go through those hassles, we don't contact Snowflake support as such to have this org admin role assigned to us. But now they are themselves giving it as a default role. One of the 6 roles are now org admin. So this is visible to us and we can see practically that thing now. So just wanted to share that. So let's let's continue with our micro partition topic. Last time we saw the demo and almost 90% was completed. There's some theoretical part that was remaining that I wanted to cover today and then move on to the next topic. Okay, so Venkat, you missed the class, but you have seen the recording, right?
Yes, Abdul.
Okay, great. Uh, so Arumugam, you had a question that, so we had created a table. So guys, I won't have those tables now here because my account got expired. Although I have the scripts and I've shared it on the drive also. So all that is gone now because my account itself is gone. So I don't have those scripts ready now. But anyway, the demo was done. So you know, you all have done the demo anyway. And what I had asked you to do was, we did demo on this schema SF100. So what I wanted you guys to do was replicate the same demo on SF1000. Okay. So if you have not done it, you can do in this week and try for yourself also, whatever we have seen in the demo class. Okay. So I wanted to show it to you from here only, but luckily I had taken a screenshot in my previous batches to show how reclustering warehouse, who is doing the reclustering behind the scenes. So it is basically the cloud service layer which does the reclustering, and we don't have to explicitly provide any warehouse to that reclustering process. So there is a warehouse called automatic clustering. This is a cloud service warehouse. Okay, like how we have cloud services only warehouse. So to handle reclustering or clustering mechanism, cloud service layer has a warehouse called automatic clustering, and it uses that to do the clustering part behind the scenes. Okay, and it uses the credits, whatever usage it will take to do the clustering. This particular warehouse will do it. So since my account has expired, I would have shown it to you, but luckily I had taken a screenshot of it, and it is the same. You have to just go to account and under the usage, you will see all the warehouse utilization. So remember that clustering is done by the cloud service layer, okay, and it uses its own warehouse. We don't have to assign any specific warehouse like we do for our query loads normally, right? So yeah. So we will discuss certain tips. So clustering keys are not intended for all tables. Okay. So last time we have seen that it's only normally clustering is not done for small tables. Okay. In millions ranges or 100K ranges, you don't need to do this because Snowflake has very rich, powerful resources in terms of warehouses where you can scale up or scale out those resources, and your query performance will be much better. Normally, we do a scale up for getting a good faster query response, right? So it is not intended for all the tables. Like, don't keep it as a first solution. Okay, there are certain criteria that you need to keep in mind before doing the clustering or assigning a clustering key. Okay, so see, what are the factors? Size of the table and query performance should dictate whether to define clustering or not. Okay, and table size has to be large enough and normally in the multi-TB range. So this is also a certification question. Like, what is the size that you will start thinking that you should do clustering? So that is in the multi-TB range. Okay, because the table has to be sufficiently large and you should have sufficiently large number of micro partitions. So the minimum size or the maximum size of the range of micropartition is 50 MB to 500 MB. We have seen that, right? So if you have a very large table, which is in TB range, then only that 500 MB and 50 MB range will be consumed, correct? So we need to have large number of micro partitions sufficiently filled. Okay, otherwise it will lead to data skewing. So Arumugam had asked a question last week about Oracle partitioning and Snowflake partitioning. So I had told you separately, Arumugam, how that data skewing happens. So did you watch the recording and understand what data skewing is?
Yes, Abdul. I understand that after that.
You got it right? Okay.
Mhm.
The other thing is the cardinality of the columns should be medium and should contain good enough number of distinct values. So the clustering column that you decide on which you want to do clustering, the cardinality has to be in the medium range, right? And what is cardinality? It is the number of distinct values for that column divided by the total rows of the column, right? So that time, last time when I was doing the demo, I had shown you those queries also. So this is how you can take out. So example, you decide to do clustering on this column, market segment on the table. So you take out a distinct number of values for this particular column market segment and you divide it by the total number of rows in your table. So that will give you the cardinality. So what is it? It is distinct number of values for that particular column divided by the total number of rows. So this should not be very large or this should not be very less. I think, okay, fine. Got it, guys? So this is the condition. For example, we have say gender, right? And we normally have male, female, and other, right? Only three values. So this is a low cardinality column, correct? Because it will be what 3 divided by say 1 TB is your table. So example. So it will be what 3 divided by 1 TB. So this is going to be a low cardinality column. Low cardinality, correct? So such columns are not good candidate for doing the clustering. That is one point. That is what they are saying here also. Cardinality of the column should be medium and should contain good number of distinct values. So one example is gender, which falls in the category of low cardinality. And it should not be too high also. Okay. So any idea what can be of high cardinality column from you guys? Any idea like which can be of very high cardinality? Okay, so let me give you, suppose we are building an Aadhaar card system, right? So we have like so many, so the population is like so much in billions, right, in India. So what will be the high cardinality? Suppose we try to create a database of Aadhaar card customers or population. What do you think will be the high cardinality?
Aadhaar card number.
Yes, correct. Aadhaar card number or yeah, exactly. Aadhaar card because it has to be unique, right? For all the people who are making the Aadhaar card, it will be unique for them. So if there are like 200 billion folks, so those Aadhaar card numbers would be 200 billion. That unique number, right? So this cardinality is huge, high, 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 right? So this is also not a good candidate for Aadhaar card for your clustering part. So it should not be low and it should not be very high. It should be somewhere in the medium range. That is one point. Frequently used columns in where clause or joint predicates should be considered as the columns for clustering. So if you guys have done if you have worked on Oracle or other data warehouses, they normally create indexes on the columns that are used frequently in the uh, where clauses, right? So although this is not indexing here, please, I'm just taking an example. This clustering is different. We have seen what clustering is till now. Whenever you are using a where clause and the columns that you are going to use frequently, that would be your, uh, a candidate for clustering key, a good candidate. So just for an example, if we are building an Aadhaar card system, what do you think could be a good uh, clustering key if we have an Aadhaar card system, right? Card system we have, if we will have what? Aadhaar card number, we will have the name, have the address, we'll have the city, we'll have the state, phone number, and we'll have what email. This will be the columns that you would have in a typical Aadhaar card system. So what do you think as technical architect would be a good candidate for clustering?
City and state. So that will lies between low and
City and sorry, city and
state.
yes, right. So it's a good candidate, correct? Because if you consider Chennai and sorry, if you say consider Pune and Maharashtra, so that could all go, in ordered way into partitions, and then you can search, you can enter your Aadhaar card number, and you can even enter your city, and you can have a quick lookup, right? So this is a better candidate for doing the clustering. Then better for tables, yeah, better for tables not changing frequently as clustering consumes compute resources and can be costly. So obviously, if there are frequent DMLs, especially updates and deletes happening, that time it is not advisable to have a cluster because it will be expensive operation. Like same in case of indexing, when we say there's a lot of DML happening, we should not be creating indexes because it creates an overhead, because it has the database has to rebuild the indexes. So in the same case, we have to do the clustering again. Snowflake has to do clustering again and again. So it is not that it will take time. Time is not a problem in Snowflake. The problem is it will consume the resources and cost will come into picture, right? So the performance issues as such are not a big challenge for the cloud technologies, because you have virtually infinite resources at your availability. So, but the problem is of costing. So you have to understand how I can save my cost. You have to be optimal with that. Order of the columns in cluster by column from low cardinality to high cardinality. So you should have, uh, when you have say multiple columns as part of your clustering key, so you should ideally go from low cardinality to high cardinality. So in this case, Venkat, you had said we will go with city and state. So what do you think should be the order of the key cardinality, so the clustering key?
That will low to high, right?
Sorry?
You mentioned something low to high or high to low?
Yeah, low to high, low to high.
Low to high in the sense it will be city to state, right?
No, it will be state to city, right? Because state has multiple cities, right? So low cardinality is state because it has less distinct values. So there are some 28, 30 states, but under each state you have a lot of cities, right? So state is low cardinality because, as I told you, what is a cardinality, how you can calculate distinct value divided by total number of rows in the table, right? So states will be lesser, and under each state there are multiple cities. So cities will have more distinct values, correct? So this is of higher cardinality as compared to state. So we should create a clustering key from state, comma, city. Understood? You got the point, right?
Yes, yes.
Right. Now, guys, we had looked at some concept called as clustering depth. Okay, it is, uh, the overlapping of the values in different partitions. That is how you calculate the clustering depth. So that is always not a perfect measurement that you need to cluster. I mean, you need to cluster your table. So we had seen that more the clustering depth is, the requirement of clustering is more. I mean, it is required for clustering, but it is not always the perfect measure. If your query is working fine, your query is giving you results in less response time, it is good enough. Okay, so that's what they are saying. Clustering depth is not a perfect measure to check if the table is well clustered. Rather, query performance should be checked. So you should always write your query optimally, and you should define warehouses properly, and unless it is reaching into multi-TB range, you should not consider clustering, because it, as it mentions, it is an expensive operation, and it uses a lot of compute resources because it has to rearrange the partitions, correct? So these are certain tips as far as micro partitioning or clustering is concerned. And right, so I already showed you which particular warehouse is doing that. Actually, it is the automatic underscore clustering. Has anybody tried the demo at all from maybe Venkat or Arumugam?
Not yet, Abdul.
Okay, because what will happen is, right, when you do that demo, right, I have already uploaded the scripts there. When you do the demo and you go to account ribbon item, and when you go to usage, here you will see that warehouse come up. Automatic clustering, clustering, yeah, this one. You will be able to see this one. Okay, so that's why I'm saying. So if you do the demo, you will be able to see this. And I had done the demo on the 100 schema, SF100. I want you guys to do it on SF1000. Okay. And okay, I was creating this free trial. This is done. Okay, close this also. Okay, so this is a little bit about the automatic clustering. So guys, as you have seen, we created the tables and we assigned a clustering key. So we did not do anything special to make Snowflake do the clustering, right? It did not do it right away, but it did it after some time. And I had sent those screenshots also. Like after the class, I saw it. I checked it after 1-2 hours, and I saw that it had clustered and the partitions were lesser as opposed to when it was not clustered. So I shared those screenshots. I hope you all have seen that. And there was one situation where we did not have a cluster table, and later on we did clustering, like we did an alter recluster, correct? So there, then also it had got clustered, and the partitions were less as compared to the original partitions when it was not clustered. So all that we did not have to do. It is seamlessly done by Snowflake. Okay, it continuously manages the reclustering. We don't have to keep worrying about it. Okay, and reclustering doesn't necessarily start immediately. So yeah, if you remember the demo, there was one table which I created with the cluster key as well, and that was market segment only. This one, this column, market segment. On this we had done the clustering. So it must be, that table must be here somewhere. Yeah, this one. So if you remember, we had created this table, and upfront before inserting data into it, we had clustered it using this clustering key. So that time, if you remember, it was not immediately clustered. It was showing still 72 partitions, which was also the same for the non-cluster table, right? So it doesn't necessarily start immediately. Snowflake takes time to do that. And later on, it will show us the result. So that is why after 1 or 2 hours, I rechecked and we saw that it had clustered it, correct? So what are the benefits? Ease of maintenance, monitoring state of cluster table not required manually. Okay. So for example, Oracle, if you're creating partitions, you have to monitor that manually, right? For example, if a new city comes in, if you're doing a list partitioning based on cities, and if a new city comes in or something new comes in on which you want to partition, you have to go and alter the table to get that particular value into the partition. So here that all that is not required. Designating warehouses for reclustering automatically done by Snowflake. Like we have to designate a particular warehouse when we are running a query workload. That is not required in case of partition, this clustering. Okay, this is the warehouse that gets assigned by Snowflake. Automatic underscore clustering. This is the warehouse. Okay, it will not be visible to us unless we do some clustering. Then full control. You can suspend the clustering, you can resume, you can drop the clustering using alter statement. Okay, so you can disable the clustering. Like if suppose even if you have created this cluster here, and say after 5-6 days you want to just disable it, you can go and say alter table, suspend clustering for this table. Okay. And later on, if you want to resume, you can resume also. And if you want to drop the whole thing only, you can drop the clustering key also. So you can drop this clustering key also. So that is also possible. And when you are
Abdul, one question.
yes.
So if we are using suspend, whatever the clustering or the partition is done already, those will go away.
No. Nothing will go away. Whatever is the state at till that point of time, it will be that way only.
Okay, so further, whenever the new data comes in, the partition will not work. So for the existing, whatever done already, it will be there. Okay.
Yes.
Okay.
In all the three cases, suspend, resume, drop. So suppose if you suspend your clustering key. So suppose we have this table here and we suspend it after say 1 month. Okay. So whatever clustering it has done till the time you're suspending it, that will remain as it is. Okay. From now on, it will load as per the order of the data. So whatever data gets loaded, it will do the micro partitioning or clustering on the order basis. It will go back to the Snowflake's default way of clustering or creating micro partition.
Okay. After 1 month, if I'm resuming the process, will it alter the data, whatever is being loaded in the past 1 month? Oh, okay.
Yes. So we have this alter. If we suppose we have suspended, okay, and we want to again resume it, and we say okay, alter table recluster. Okay? We have resumed it, and we have to say recluster also. So that time it will rearrange again the whole thing.
Okay.
The whole partition, the clustering. Let's not call it partitioning, clustering. Okay. And so good point you raised, because and if you are parallelly working on that table, you are doing certain DML or something, it will not block you. It will happen at the back end. Because as I said, Snowflake doesn't do it immediately when we say recluster. So it does it at its correct time, whatever algorithm it is running behind the scenes. So it doesn't block your DMLs as such. It will not, ideally, it will not slow down your DML. So you won't see any effect of automatic clustering or reclustering happening on your table as such. Optimal efficiency allows Snowflake to dynamically manage resources need for reclustering. Reclustering is triggered only when table would benefit from the operation. So this all decision, even if you tell Snowflake 1,000 times that cluster on this, if this algorithm allows it and it sees that there's a benefit for the table, it will do it. Okay. So in your hands, it is to just say that cluster it. But Snowflake has its own algorithms behind the scenes which takes care of it. Okay, so it will not be triggered immediately. So that's why last time when we had created this table and we were wondering why it's not properly clustered. So that is the reason it doesn't do it immediately. So after I checked it after 1 or 2 hours, we saw that there was a difference. The partitions, the partitions, micro partitions were lowered down from 72 to it came to 50. So that's why I'm telling you, do this demo on the, so I have done it on SF100. You guys do it on SF1000. That's what will help you to see things for yourself also and become hands-on. Okay, and where do you see the billing? You have seen this screenshot here. It is under the usage. Go to accounts and see on the usage, or you can go to automatic clustering history also. So this is available in the account usage schema. So if you go to Snowflake here, we have account usage schema here, and this is your account clustering history. Here you can get the details. So if I put preview data here. So guys, see, I don't have anything. This is a fresh account I created today. Everything is gone. So once you guys do clustering, you will see certain information here. Okay. See, so what are the performance tuning as a Snowflake developer that you are supposed to do. There's no indexes. There's no concept of indexes at all in Snowflake. Okay. There's no table, don't need to create table partitions. You don't have any partitioning concept. I mean, creating partitioning by yourself. There's nothing like that. And query plans also you don't create. Snowflake Cloud Service Layer does it. You don't need to manually cache results. Okay, Snowflake does the caching itself. There is something called as hints that we provide to the Oracle optimizer. So if anyone has worked on Oracle, we pass hints to the Oracle optimizer, that, do this query in parallel, assign eight processors to this query, or, use instead of, so if you have multiple indexes on the table, you say, use this particular index for this query. So all that hints you provide to Oracle query. That is also not required. Transaction management also is not required. Primary key, foreign key, unique key there's no enforcement of these constraints. Okay, although although you can assign a primary key on a table, you can assign a foreign key, you can assign a unique key, but it will not enforce those constraints. Okay, for example, let's create a table here quickly. For that, I need to create a database. Okay. Call it DemoDB. Okay, I am in DemoDB now. I don't know why they have removed this. I was also very surprised when I kept telling my weekday batch that, are you able to see a demo DB here? And nobody was able to see it. I was like surprised what happened. Yeah, anyway, let me refresh it. So we have demo public, and I'll create a table. C1. I hope this. No problem. Constraint. Create table name, column type, and then primary key. So this is the syntax. So we have created a table called as demo tab, and we have one column in that table, and we have said that it should be a primary key. So as you all know, a primary key is a column that cannot have null values, and all the values have to be unique, right? That is what a primary key. So guys, do you have any doubts in what a primary key, foreign key, or unique key has? Any doubts in this?
No, Abdul.
Sorry.
No, Abdul.
Okay. So unique key, can it have null values?
That's my turn.
My question to you guys: can you is unique key? Can you have unique key in null values?
Yes, it can, right?
Yes, that's right. And what about Shiva? I'm putting you on mute. And what about foreign key? Can you have a null value in foreign key?
Foreign key, just a reference to that
Foreign
key, right?
key,
So
you can't have
can't. I
Okay.
primary and
think
foreign.
it.
Okay. What Arumugam, you are saying you can't have?
No, it can.
It can. Okay. Venkat, you are saying?
It can, but result will not fetch correctly actually.
Yeah. I mean, so you can have null value there, right?
So I think so. We can.
Okay. 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 What about Shiva? Do you think foreign key can have a null value?
Foreign key can have. That's what I believe.
Yes. Yes. So guys, foreign key can have null value. Okay. So that is correct. So although the idea in Snowflake is, although you can define the primary key, foreign key, or unique key on a column, but Snowflake will not enforce it. And why Snowflake has kept this? I mean, what is the point in keeping this if you're not enforcing it, right? Why you want to keep it? So why they have kept this for the migration projects and to create an ease for the migrations. Okay, guys, can you go on mute, please? Okay. So, like all our traditional databases and traditional data warehouses, they normally have these constraints, right? Primary key, foreign key, etc. When you are going to migrate, say from Oracle to Snowflake, and if you want to import the table definitions as it will do that for you. Okay. So for the sake of migrations and also for the data modeling, like when you want to say you import all these tables into say one data modeling tool, and it will automatically show you the relationship. So it will create those boxes of tables, and it will relate with each other columns for the referential integrity with each other table columns, and it will highlight what are the primary keys and all that. So for the sake of understanding the design or the ER diagrams, so if you pass on those tables to that data modeling tool, it will show you the relationships and constraints will be part of that design. So for that reason, and also for the ease of migration, they have provided this. So let me insert some value here. Insert into demo. Okay. It's got inserted, and again I will insert the same value. Okay, so even though I have assigned a primary key constraint on this column, still it has allowed me to insert the duplicate values. Okay, so I have two duplicate values here. So it doesn't enforce primary key. You will never encounter memory exception, out of memory exception. So because there's no space issue, because we are using cloud services behind the scenes. In case of AWS, it is S3, Blob, Azure, and Google, it is buckets, right? So you don't, whenever you have space issues in the backend, Snowflake automatically scales it out for you. Scales it up, not out, sorry, scales it up for you for the storage part. So what is that you have to do? Okay, so all this 1 to 8, you don't have to do as a Snowflake developer for performance tuning. So now what do you have to do? That is the part we are coming to now. So you have to firstly sensibly use the tool. And how can you do that? Focus on reducing the compute cost and focus on reducing the storage cost. Okay. You need to have a proper clustering strategy. We just saw a few points, right? You should not consider clustering unless your table is in the multi-TB range. You should uh, take clustering keys which are frequently used in the where clauses. They should not have too low cardinality. They should not have too high cardinality. And some more clustering strategies we just saw some time back. It should not be a frequently changing table, which means it should not have a frequent DML going on it, right? And you should see how you can share your virtual warehouses in a particular team. For example, QA and dev, they can use the same virtual warehouse. You don't need to have a separate warehouse because their activities are not heavy, right? So what is the dev guy going to do? I mean, dev guy is going to anyway create queries, create procedures, functions. That creating that doesn't require compute services. Of course, to execute and the unit test, it will require, but when you're unit testing, you will not be doing it on a heavy data. And QA also will not be normally doing it on a very, very heavy data, right? So they can share the virtual warehouses. So these are some of the things that you can look at as a Snowflake developer. And most of it is related to controlling the cost. And it is, only two costs, majorly two costs are there: compute cost and storage cost. So we have come to end of micro partitioning topic. And as I said, again, I'm reiterating, please do the demo as an assignment. I have already done it on SF100 and shown it to you all. I want you guys to please do it on this schema, SF1000 here. This one. Okay, so it has, we did it on what? We did it on customer table, right? So, and we did the clustering on market segment here. So if you look at the size here, it is 10 GB. And the one that we did was on 1 GB. Okay, so please guys do it on that and please see how it goes for you. So before you move on to the brand new topic, any questions till now?
So Abdul, the SF100 is the schema name on the shared database.
Yes, yes. This
With
Snowflake sample
data. Okay, sample data. Okay.
Yeah.
So you create a table using as select from these tables. So source as table, and you are watching the clusters or partitions.
Right. So yes, that's right. So I created a table from that definition. I mean, I just took the columns from there. Okay, and you can get the DDL also directly if you want.
Okay.
Did I think I've shown you the command for getting the DDL of a table, right, guys? This one. Yeah, that day only I showed you, right? So this way you can get the DDL. So this is a function. You can pass what DDL you want to get for which object, table or view. You can pass the table name. Not supported on shared database. Okay. Okay, so that anyway, you will not be able to do that, I think. But if you want to get a DDL, you can do it on your tables like this. Okay. But why is it not allowing? Right. I think it's because of the security. Let me see. This is a shared database, right? It's secured. Yeah, it's not supported. So you will not be able to see the definitions. So you will have to create it using here. Or I have anyway given the script in the drive. You can use this directly. Just change when you're inserting the data here, insert into select star from this, just change from 100 to 1000. That's all. You can just open the script. Okay, copy it somewhere on your local. Just say replace 100 with 1000. Or if you want to be a little more careful, just do it SF100 with SF1000. That's all. It will replace it for you. And then you can follow the demo and follow the scripts and look for yourself. Cool. Yeah. So Shiva, yeah, I hope that answers your question. Anybody else on micro partitioning? And Shiva, I have told them that I had created my account today again because it got deactivated. So today I created my new account again with the same email ID, and there are certain changes that have come up in the new creation of accounts. So watch the initial 10 15 minutes recording, and you will see what what changes they have come up with. For example, they have come up with this new role. I mean, this role was already there, but they have now assigned it to you directly. So if you click on this role, you will see the organization ribbon item here. So you remember the top? Yeah. So at the top.
When we were addressing the questions of Venkat,
right.
Then we have gone through these documents and we saw an accounts can be tied into an organization.
Right. So now we can see visually for ourselves also. Thankfully, they have started to give this role now. Because I have this morning weekday batch going on. So I just recently got the accounts created for them, and I was telling them that you might be seeing 5 roles here, but they said no, we are able to see 6 roles. So I was surprised, and I asked them to share their screens, and then I came across this org admin has been now getting assigned. So then I asked them to switch it, and then I saw this ribbon item, and here you can create multiple accounts.
Yeah. What we are creating are you able to create a Azure account also? What is that?
Yeah. So this is same like you create a free trial account. All those options are same here.
Okay, so which means that a Snowflake organization can have the account created in a different cloud itself.
Yeah.
Yeah, right. We can choose, for example, when we create an account, we choose AWS and all. This account can have organization can have account of different cloud platform. That is
yeah.
So we can create the same. That is what we are doing now in our client. We have some jobs which is populating data in both Redshift and Snowflake. We are comparing the cost and performance. Whatever it suits for the business, they will retain it and they will get rid of the other platform. That is what we are doing. Yeah.
Okay.
Good. Yeah. Thank you. Yeah.
Okay. So visually, this is now possible to see. Otherwise, we just had to talk about it because it was not assigned to us. We would have had to take those hectic emails with support team. But yeah, so once this account expires, right, and you recreate your account, you will be hopefully seeing this change. And also they have removed the default databases, DemoDB and UtilDB. They don't provide it now. They just give these 2 shared databases, and I just created just now. And because of this new account, all my scripts are, I mean, whatever was there in my database, it's gone. Okay, cool. So let's guys move on to the next topic for today. That is ACID properties. As database professionals, I'm sure you all know what an ACID property is. This property has to be adhered to be called, basically to be called a database management system. You need to be adhering to these properties, and they are called as ACID properties. Okay. I cannot just have an Excel sheet open and create certain 100 Excel sheets and say this is my database management system. Anybody will call it storage system, file system, or database management system. It has to adhere to certain qualities. For example, how cloud is also, to be called a cloud, you need to adhere to certain standards. Like you should be highly available, you should be paying per use, you should be connected over the internet, and you should be given any kind of service. I can just keep my laptop as a compute resource and advertise in the market and say my compute resource is available as a cloud. It doesn't work like that. It has to adhere to certain standards. So similarly, to be called a data warehouse or a database, you need to adhere to certain standards, which is ACID properties. Okay, atomicity, consistency, isolation, and durability. Okay, so I'm sure you guys are all have worked on databases. You have heard of this, right? All of you? Anybody not heard? If you want to share, if you have not heard about this at all. Okay, good. So yeah, so ACID is a concept that refers to the 4 properties of a transaction in a database system, which are atomicity, consistency, isolation, and durability. These properties ensure the accuracy and integrity of the data in the database, ensuring that data doesn't become corrupt as a result of some failure guaranteeing the validity of the data even when errors or failures occur. Okay, so these properties, they are revolving around a particular transaction on the unit of transaction. What is a transaction? When you're doing some DML operations, that is a transaction, right? When you're inserting a record, maybe a sales, or when you're updating a record, maybe somebody's Aadhaar card details, maybe you're updating a phone number for a person who has come for a change request for a phone or an address, or you're trying to delete certain records from some system, right? So that what happens to that transaction in case of a failure? Okay, what happens to that transaction when other user is trying to access that data? Does it see the latest data? Does it see the old data? What happens to it? Okay, and if there are 100 requests, say I have an update of 100 requests on Aadhaar card. So does it impact the other transactions? Okay, so all this comes under atomicity, consistency, oscillation, and durability. So we are going to do certain practicals on this asset properties, and we are going to check how it happens, right? For example, we will start with the very first demo. What I did was I just inserted 2 records here, right? If I go to the other worksheet here, or even if you want, I will go to other session also. I mean, these are also other sessions only, but I will open a new window, totally new window here of the same account. Okay, and to compare, I have opened one Oracle instance also. I had installed it quite some time back. Let me go to, so this is my Oracle database. Okay, I have opened it. So what tables do I have? So, okay, so I have some employee data in my Oracle instance, and I will open one more Oracle instance. Maybe some other user is also logged into the same database. Okay, concurrency basically, multiple users logged into the same database. I will fire it on this also. Fine. So if you see here, I had inserted 2 values here, and I will go and query this same table from the other URL which I have opened here. Okay. See, I am able to see 2 rows which I had inserted here. Right? Here, I'll try to insert 1 row. So I will add 1 employee ID and maybe 1 name. Okay. Yes. Okay, 1 row inserted. So I have basically just inserted 2 columns only. So if you see here, I have inserted 1 row. This one, I just inserted, right? Now, so I have one more user which is logged in. It's from the other system. And let me again go and fire the same query. See, do you see that record here? No.
We haven't committed, right?
Right. Right. But have we committed here? when we inserted.
We have that auto commit in Snowflake, right?
I inserted one more record here, okay? And if I go here, and I'll be able to see it here again. So, but what if you enter something wrong? Can you control that? You will have to, if you have inserted, okay, this is one column, that is one row, that is fine. If I had some 100K rows and I inserted, and some row in between got failed and some got wrongly inserted. The values were wrongly inserted. I mean, I created a wrong data set. Some got failed, some got wrongly inserted. So I have got no control in this way, correct? That is a practical question, right? It could happen. So although Snowflake provides you an auto commit when you are doing these things, okay, but you can control it as well, right? So there is a begin and begin and end kind of a block they provide to you, and they ask you to set the transaction. So we'll see how to do that. So in Oracle, this is on any traditional databases, it is not an auto commit always. Okay. So it will wait for you explicitly to commit. So if I commit it here, and once I go here, now I am able to see it. Okay. Or if I say add one more employee here, and I insert it, obviously I'll see it here, because in that particular session, it will be visible to me. Here, it will obviously not, because I'm not committed. But if I want to roll back, I don't want to insert this record due to XYZ reason, so it will go off. Go off from the same session also. And anyway, it will not be there on the other session. Correct? So this rollback and commit, I'm able to control it. So in Snowflake, it is not like that. You have to control it using the set transaction command. The begin, this one. So when you say begin, you have to give the name of the transaction and whatever transaction it is, you give that, and then fire your queries under this block. So what I'll do now is I'll go back to my Snowflake account here. Here. I will say, so this transaction name, you can give anything, guys, okay? Then I will insert again one row, suppose. So right now we have 3 rows, right? 3 rows we have, okay. I'm inserting a 4th row. I will say begin, it has created a transaction. And I have inserted 1 row. So now there are total 4 rows. I go here and to preview data. 4 rows, correct? Now here, if I go to the other session, see, it is not, it's not giving me the 4th row, because I have confined or provided this transaction under some transaction, some particular transaction. This is a part of particular transaction set. Okay, here I can have multiple rows, multiple inserts or DMLs, updates, etc. Okay, so this is part of one transaction set now. And you can select that transaction through this particular context function. So this is that current transaction. Okay. Now, what if you go to the in the same account, if you go to the other worksheet, this worksheet, what happens then? See, this also is 3 rows only. So this is how you can control, whether you want to. So what could be your, business logic, that if all my transactions under this transaction set T4, whatever is below this, like 100 statements or 5 statements, 10 statements, If all of them are working fine, there's no error, then I will commit it. Otherwise, I'll roll back. Okay. So this is my commit. I will fire commit now. And I did this. And now let me go to the worksheet here in the other session. See, now it's reflecting. And here also it's reflecting. So this is how, guys, you can control the commit, rollback, etc. And if I
It's the same what you do in SQL also, Microsoft SQL also.
in what? Sorry,
SQL, Microsoft SQL.
Microsoft SQL. Yes, yes.
Same processes.
Correct, correct. But in Oracle, it doesn't do an auto commit as you have seen here. This when I opened this. So here you have to explain. I mean, there's no need of keeping it as a part of transaction. Although you can do that, you have this set transaction facility there, but you don't explicitly need to do that. It will be anyway not auto commit in Oracle. So say I need to, okay, if I go here, see, I have committed, so it's no more there. Yeah.
Abdul, see here, there's a problem here, right? For example, if I have it, so which means that you are saying only one transaction can be created at the same time when for the single user, right?
One transaction means this one statement.
Yeah, for example, begin name T4, right? Now we created the transaction, right? And inserted you did not commit. Yeah. For example, can I have begin name for name T5, T6, T7, T8, right? But I never committed any one of this. So if you put select current from transaction, what will happen?
So you will have those many transactions. Huh?
Yeah, for example, at the same time, you are saying we can have only one transaction, right?
No, I will not say like that.
Yeah, if you put run all these 4 transactions, all these 3 transactions. Let's change the values 2 or 3, something like that.
Yeah, keep their transaction number.
Yeah. Now we will have 3 transactions, right? Run all this 3. Yeah. We created 3 transactions now.
Yeah.
Right?
Yeah.
Put select current transaction, which means what it does. It is the last transaction it brings.
Yeah.
Which means that transaction T6, the number which ends end for.
Okay, let's do one thing. Let's just commit it again, and we'll again do it. We'll do one by one current transaction. Okay. Like once we.
Yeah. To want to see, right?
Yeah. So
I just want to check how many open transaction can be there. Is it more than one, or we can have many number of open transaction at the same time?
Yeah.
That is what my question. Got it, right, Abdul?
Yeah. So you can have many.
Yeah.
So let me run this one first without committing.
Okay.
And I will run this here. I will just copy paste here and copy that value also.
Yeah.
Okay. This one.
Yeah.
And I will not commit anything. Okay.
Yeah.
Here. And this is my other transaction. Let me run this as well.
Yeah, different. Same transaction.
So it's save only. So this is a part of session transaction.
So you could put the select star from the table.
From?
Select star from the table.
Select star from current transaction.
The table.
Okay, this table. Like that?
Yeah.
This way?
Yeah. So maybe what I think is your expectation is the
So this is not a transaction actually. Transaction is mostly DML. Yeah, go ahead, go ahead.
I think doubt is that when you do the begin trap, after you insert a multiple insert, whether if I put a select, whether it displays or not. That's what I think should.
Okay, so let me do one thing. Let me just commit the first transaction. Let me commit it here. Okay. So see.
No, it will commit everything, right?
Yeah. Yeah, that's what it will commit everything. Yes. So basically you can have, I mean, your transaction is one, but under that you can have multiple statements, multiple transactions.
Is there any way commit the transaction name? In Oracle supports, you can commit only the given the begin name. Commit T7 like that.
Okay,
Commit
okay.
like that. Oracle supports this, right?
Okay, okay. That way you're saying. Okay, got it, got it. Sure.
In a single session, practically in the production environment, we have a multiple transaction, not only single transaction.
Yeah, I got your point. You're saying like this, this.
What is the name? It's a transaction name.
Yeah, transaction.
Yeah.
Oh. No, there. I'm not remembering the syntax. There might be something there.
Commit name T7. Commit name T7.
It would be something like transaction or something.
Oh.
Okay, I think it's what you are saying is not there.
Right, I should be, for example, if I have a 4/5 open transaction, if we want to commit only specific transaction, to close one of the transaction and keep other 3 transaction open, so which means that there is no option.
In SQL also we don't have that option actually. So when you are in production environment, if you are commit option, we should comment the other line only. We should be careful when you are handling commit. We should comment the other lines actually. In SQL also we don't have that option.
I think Shiva, what you're talking about is right. Commit normally doesn't have a transaction point, but a save point has. So Oracle has commit, rollback, and there is one thing called a save point.
Yeah, that is what save point is the create a transaction. Whatever you are saying, begin name T1, right? That task can be achieved by save point.
Save point is something where you want to commit till a particular point. That is the save point in Oracle. For example, you want to commit or roll back up to certain point of transactions. So that is what is a save point. But commit, if you want to commit a particular open transaction, firstly, I don't think, I mean, I have never used this set transaction in Oracle when I used to work as PL SQL, because we did not have anything like that, right? Because Oracle is anyway not self-commit. If you do an insert like this, it's not a self-commit. It was always, if we used to, put it inside a begin end block, if there is an exception, we will roll back. If there is no exception, we'll commit. So there is a begin, and then there is a, this is transaction, there is an exception block here. If there is some issue, something to roll back. If there is no issue, then commit. This is how we handle in Oracle. So as such, we have never used the set transaction, which you're talking about for Oracle. And the thing you are talking about is that you need to commit at certain point of transactions. That is called a save point.
Yeah.
So we can quickly go through, no problem.
No, it is fine. I don't want to waste the time. So
Okay.
you got my questions, right? For example,
Yeah.
even if I create a multiple transaction,
Hmm.
if I commit, all the transaction is getting committed, right?
Yes.
In the Snowflake, we have a name T7, T8, or T9. When you say commit, all the transaction is getting committed.
Hmm.
There is no way of handling multiple transaction independently, right? In the Snowflake, that is what you mean to say.
You are saying about, suppose if I have 10 inserts here, if I have 10 inserts here, and you're saying if I get in, if you're saying if I have, let me commit it here. So if you're saying if I have like this, and suppose this second fails, how to control that, you're saying that, right?
Yeah.
Okay, so see, normally you will write this as a part of procedure. So you have the try and exception block there.
Try and exception. Okay.
Yeah. So okay, you have
No,
worked, anybody has worked on PLC?
Abdul, you proceed. We will talk later. Maybe.
Okay, when we come to procedures part, right? Procedures part,
Yeah.
that time I will show you how to do that.
Yeah. Yeah.
Okay. Because this will be a part of program, some procedure.
Yeah, it cannot be in a SQL.
Right.
There's no need. There is no need to be in SQL.
Right. Only if it's a release, then it will be a SQL. If there is a release, you want to insert some one-time data, or you want to create some tables, etc. That time it's in a single SQL file. But normally the batches or the automatic tasks that are happening behind the scenes are in the form of procedures, functions, and all that. So to answer, I mean, not exactly answering your question, but you can have multiple statements under the transaction here, like this. You can create any number of inserts, updates.
That is understand. That I understand.
Yeah.
That is when it is called a transaction, right?
Right.
Transaction is having, for example, if you say a transaction, which will have three records, three insert in different table, one insert, one update in one table, one delete in another table, then again insert. It's a combination of some insert, delete, update operation. Then that makes a single transaction.
Yeah.
Right.
Yeah.
To control that, we are having this transaction.
So have you worked on PL SQL? Oracle PLSQL. Have you worked on Oracle PLSQL?
Yeah, I worked.
Okay, so you are aware of this structure, right?
No. This is a very common structure. Every time we write 4 or 5 independent transactions inside the proc only. Right. We independently handle a couple of transactions inside the proc. Right, the outer transaction will behave differently. The inner block will behave differently. These things are all very what is that? Not in-depth writing way, right? It is the maybe if you write a sample program, you can write like that. But in real time, when we have the package of 5,000 lines, multiple transaction, we will have a multiple save point, 5, 10, 15 save points independently inside the program.
Yes. So that's what I'm saying. You have worked on PL SQL, so you are aware of this structure, right?
Yeah.
So you have to use this structure only to have multiple. If there are 15 different transactions and you want to have your save points, there's no other structure in Oracle or PL SQL other than this. You have to logically use this structure only, and there is something called as autonomous transaction also, where when you're doing.
We have the other structure also to have a sub program inside a proc being committed or rolled back differently. We have other options also.
Which option?
Yeah, that is a transaction, right? Save point.
No, you write.
Yeah, save point, right? We created an external transaction, save point, commit only that save point. Yeah,
okay.
Abdul,
anyway, we can.
Yeah, that's what we can deal with that.
Okay. Anyway,
we'll try to do it. If not, I will call you. Yeah.
Sure. So what will happen is we will have one try exception block later on, which you will see. And that's where you can control all these different transactions, like which to commit, which to not commit, and all that, in case of error and all that. Okay. So yes, so basically to control your commit rollback, you can put your transactions in this. Otherwise, if you don't give this, Snowflake will go and simply commit it. It is not a rollback way. You will not be able to, roll back. Of course you can do it, but automatically you cannot roll back. So this is the way to do it. And now we have to understand how update will basically what do you call, impact our transactions. Okay, so this is, guys, this is, I just created the primary key and showed you that it doesn't impact if we violate it also. Similarly, if you create a foreign key also, and if you violate the foreign key also, it will not impact. Okay, I'll just quickly show this to you. The only thing that can be enforced in Snowflake is when you say that this particular column is not null. This will be enforced. Okay. So primary key, foreign key, unique key is never enforced, even if you define it in the table. And when you define a constraint call as not null on a particular column, it will be enforced. So see this. So I created, what happened? Table does not exist. So
The foreign key, the supplier test, right? The parent table is not there.
oh, okay. So I have created one table, two tables. So this product test is basically a foreign, the supplier ID in this product test table is a foreign key to my supplier test table, which is the supplier test table I just created here. So we have enforced a foreign key. So let me insert product test. So see, even this supplier test is anyway empty, right? So either the foreign key column should have the domain values from the one it is to the column it is referencing. So in this case, the product test supplier ID is referencing to supplier ID of supplier test. So whatever values are there in supplier test, it should refer to them only. For example, if I have 1, 2, 3, 4 as my supplier ID values in supplier test, okay, this is my supplier ID in supplier test. So I am, by the rule of foreign key, I should be able to only insert supplier ID as these domain values only in the product test table, which is referencing as a key, as a foreign key. So if I say insert 5, okay, so product ID is 1 and I say supplier ID is 5. So it is violating the foreign key, right? It is not a part of this domain values. So see what happens. It's not enforcing. Okay. So that, as I said, it doesn't enforce. Now I have said that these two columns are null, not null. They cannot be null. Okay. So if I say try to insert this second row here, see, it will not allow me because null result in a non-nullable column is not allowed. So this is enforced. Not null is enforced. So it's a small thing, not a very complicated thing. Just wanted to show. Yeah. The important aspect to understand is of update. Okay. So let's look at Oracle. Okay. This is my first session and say I'm updating EMP table and I'm going to set, say, SAL equal to say 1000, where my EMP NO is 7839. Okay. And I'm not going to commit it. So I'm going to update this first row salary to 5000. So original is 5000. I'm just keeping a track. I updated it. Cool. Now if I if I see, it has updated in the same session. if I go and do a select on the other one, other session, no, sorry, not session, other login. See, I still see the original value here. Okay. Say if this is also trying to update the same row here, let's say value as 2000, suppose. So what do you think should happen?
It will wait. It will not allow it.
Yeah. So it waits for that transaction to happen. So this is called as integrity, right? It is maintaining the integrity. So it will first allow, it will not do it unless this is committed. So now let me commit it here. I have committed. Let me see the value. It's 1000 here. Okay. Still 1000. But here it has released the log and said one row updated. Let's see. If I go here, I'll see 2000 here. Correct. But as soon as I committed it, committed this transaction here for updating as 1000, it released the lock on the other transaction and said, okay, now you're okay to update, and it updated it 2000, but still it has not committed it. It has only committed the transaction which was in progress, because we were operating on the same row, this 7839 row, this first one, we were operating on the same row from both the sessions or both the different sessions, right? Now I will commit this too. So here anyway it will reflect. If I come here, it's changed from 1000 to 2000. Now I'll do another thing again. I will do another update again. And same row, maybe I'll update it to 3000. And let me go there to the other one. And here maybe I will update 76982. This is my original. And I will update it to say 1000. Okay. Let me update this. One row updated. I have not committed anything. Okay. I can see the value here, although it's not updated, I mean committed yet. If I go to the other session, I will still see the old value here because it's not committed. Now I'm going to update this row. So what do you think will happen? Will it allow me to update?
Sorry, Abdul, you committed the record in the other session?
No, not yet. See, I updated for 7839. I updated as 1000. Okay. Sorry, I updated for 7839. I updated as 3000.
Okay, you did not commit.
No, I did not commit. So this is 3000 here. Okay. If I go here, it is 2000 right now. Okay. Okay. Now I am updating 7698 here as different 1000. Row. Yes.
Different row, right?
Yeah, different row.
It will allow.
Okay, so it will allow. So basically, it locks on a row level. Okay. Let me roll back. And roll back. So you understood, guys, when you are operating on the same row concurrently, it will lock it unless the person who has gained that particular row for its operation commits it or rollbacks it. Either commit or either rollback, whatever it is. Okay, so until then, it will not release the lock for other users who are working on the same row. That is important. But if in the same table, people are working on different rows, that is fine. They're updating on different rows, that is fine. Okay, for insert, there is no lock, obviously, because everybody is inserting a new data. There's no lock. Now, let's see what happens in Snowflake. Little interesting. So I'll just create it. Create a quickly one database and insert some sample records quickly. Cool. So I'm creating a sample database and I'm creating one table. So guys, as I told you in the last lecture, don't worry about this transient. I'll explain it to you when we come to that topic. I'll create one customer no cluster table. Like from, let me create it from a smaller schema, guys. Otherwise, it will take a lot of time. Okay, this is created. This is our cluster table. We can define it like this. And if you want to see certain rows, this is the data set. Okay. So the same table we have used for which we had done clustering. Okay. Now let me remove all this. Now what we will do is we'll see update behavior. And this. So what I'm doing is whatever market segment values are furniture, I'm changing it to furniture. Simple thing. Let me bring it to this worksheet. And what I'll do is the other update. Where's the other update? Okay, so this update, or I'm doing on the furniture segment, I'm making it as one. Sorry, I'm renaming it as Fernie, and in the other session, some other concurrent session, I am updating furniture as Fernie 1. Okay, so let's see. So here I execute this first. Let it get executed. Okay, so number of rows updated is so many. I have not committed it yet. Let me go here. See, blocked. Status is blocked. If I come to this here, status is succeeded. This is blocked because it has obviously blocked the rows like we have seen. Let me go and commit it. Or no, I will not commit it. I don't want to spoil the data. Anyway, even if it's spoiled, doesn't matter. See, it automatically released the lock and got success. And now I can commit it or roll back on it. Roll back. I'll just roll back. Okay. So this is the expected same behavior, right? Now, what else? What other segment do we have? Let me just quickly have a look. I have building. So I am operating on a completely different data set now. Okay, building, and let me make it building 1. And here I'll re-execute this statement. This is a completely different data set, right? What happened? Did I roll back this? Guys, did I select this whole thing?
This is showing funny one, right? Check the other tab whether you executed commit or rollback.
No, I executed rollback only here. But here, while selecting this whole thing, did I select the whole thing? That is, wait, let me just do that again. Funny. Sure.
No, Farney hyphen one.
Right. Okay. Okay, let me again do it. First, this is my statement. This is my update that's happening. Okay, let me see the distinct values. I have funny here. Let me go to the other session. I should not see funny. I'm seeing funny one here. System level, guys, let me edit something wrong. Let me just drop the database. Okay, run update. Funny, yes. So in the other session, I will see what it reflects. It should reflect for teacher only because I have not committed it yet. Yeah, this is furniture. Okay. Now I'll just create one more transaction here. Make it T2 and I'll save, make it funny one, and I will run it. It's not running, it's blocked. Okay, because it's locked. You can see on the worksheet level also the status blocked. If you go to query history also, it will show you blocked. That status we have, right? So now let me roll back. Roll back. Cool. See, it has come back and done its commit. Funny one. Now let me see the distinct value here. Right, we roll back, so no issues. And here it is funny one, correct? So if I commit it here, maybe I'll just commit it, or if I roll back also, it will roll it back to furniture. So let me go back. Okay, go back here. It's back to furniture. If I come here, obviously, it'll be back to furniture. I think when I was firing from here, right, instead of selecting this whole thing, I selected only this much. So it got committed. Maybe that's the reason, we saw some discrepancies in the values. So, okay, so this is, so what I was trying to show you, what we did just in Oracle, we tried to do update on the same row. The other transaction got locked. And we did on separate rows. So obviously they were independent transactions. So they were not locked. And here again, I'm working on a particular rows data set of furniture and same here also. So it got blocked for certain time till I released this transaction, either through commit or either through rollback. Now we'll go to the other situation where we are working on a different data set completely on the other session. So I'll make it building one. So I'm going to update building to building one here, and here let me first run this because I select anything and then things go wrong. Update. So I have again updated furniture to funny. This is funny now. Let me go to the other session, still furniture because I'm not committed there. Now I will work on a different row set entirely here. Okay. Update. Sorry, I started a transaction. And let me update this. What do you think should happen, guys?
It should allow.
Right. See what happened? Blocked. We are not working on the same data set here, right? We are working on a different data set.
Because of the columnar loading.
But yeah, I mean, we have different databases also. Have you worked on any NoSQL columnar database in the past? Mongo, Cassandra? Anyone? I mean, not only you, anyone.
No, sir.
No one. But guys, this is a behavior that Snowflake basically locks the whole thing.
This is because of the block storage. Oracle uses block storage. Here, S3 is not a block storage.
Block storage, yeah, correct.
Yeah.
Object storage, yeah. S3
It's
is an
object
object
store. Yeah,
right.
it's object store. The whole table is placed in a single object.
Right.
So since the block level granularity is not enforced in
Right.
Snowflake, they don't have a capacity to
Right.
set the transaction at row level.
Right. So it is not possible at row level. Also, the other reason is one micro partition can have multiple rows. So as I told you, I mean, one micro partition can have different column values, and a micro partition is immutable. You cannot simply change one row inside a micro partition. If you even touch one row in one micro partition, that whole micro partition gets deleted, logically deleted, and then a whole new partition gets created. So update in Snowflake is actually delete and then insert. It is not update on the same data. Okay, so behind the scenes, update is actually a delete first, logical delete, and then insert, right? So we saw that in the last class. So yeah, so I just wanted to show you the difference, guys, like in the traditional databases here and here, it will log the whole thing because as Shiva said, it's a behind the scenes when we discussed about what S3 is. So we had seen it is an object storage, right? An object storage means you store the whole file as it is into the storage. Unlike unlike block storage, which Hadoop also follows, the HDFS system, they take data in form of block storage. And what they do is they divide the whole file into small blocks and then put it onto the different nodes. So this all we have seen when we were discussing S3, and we will see it more when we come to data loading. Okay. So because of object storage and micro partition can have multiple, it is immutable, right? It cannot be, there can be no changes within a micro partition. If you have to do any changes, you have to first discard the whole micro partition, delete it, and create a new micro partition altogether. And that is why, because it is an object storage that we use across the clouds. So S3 is also blob object storage, Blob is also object storage, and Google, whatever it uses, is also object storage. So I had sent you one AWS cloud services list on WhatsApp. So if you look at what are the different object storages in across the clouds, you will see that in the WhatsApp I've sent. Okay, so this is the reason, guys, right? So I have released it, I rolled it back. I did not change the values. And here, I think I have not rolled back yet. So building one is still there. I will roll back it. And if I go back there, I will not be able to see building one. I'll still see building because I have not committed it. So just to show you commit also once, I will just commit it. Okay. Obviously, I will see the changed value here. And here also, I will see the changed value because I committed. Okay. So yeah, some people were a little surprised from my previous batches, like why this happens. But yes, so this is a little change in the behavior you see compared to your.
The takeout is Oracle and the traditional databases locks at row level, but Snowflake locks at table level. That is what we have to.
Yeah. Exactly. Yeah. So the last thing in this asset is that, see, let me do a select star from stable, or that will not be suitable. That example is not suitable for this level of data set. Let me put some more data set. Let me drop this table first. And guys, I'm sorry you guys had to wait for the class a little late. But yeah, next time we'll make sure that we start on time.
Whoever is unable to make it, I think we can see the videos.
Yeah, sure.
Yeah, because we don't want to this class to go for another 3 months, right?
Right. But there are many topics left, okay? Because I am not going to.
That is what I came to know. Armagam called me just now. He said there are 30 classes more.
Yeah. So if you go into normal Snowflake classes, they will finish in 30 hours. That is
that is what. 20 hours, 25 hours.
Yeah.
They will finish it. Our class is more of practical and interactive sessions, which may take another 4 or 5 classes, right? So
weeks.
Yeah.
Right. So guys, see, notice this here, because the example I want to show you needs more data. So I'm taking the highest possible data set, increasing the schema size here. So it will take time. So I'll go and resize my warehouse. See, I don't have any customized warehouses also. Just created the account today because it has got the other one got deactivated. It doesn't deactivate the account. It says now your trial period is over. If you want to get into the BAU account purpose, you have to put the credit card details. So let me make it large. Okay, let me make it large, guys. Okay. Why to make it large? I'll make it 4 medium. I'm resizing it, making it a little powerful, more powerful, and I will insert all this data. Schema, okay. I think it's only 1000. So I have if you see, I have resized to medium, that is 4 nodes for per cluster. And Shiva, why you were asking about DBT? Do you have requirement of that?
No, I was applying for some positions. So
Okay.
they asked DBT. I don't know what is DBT. Then I was curious to know.
Okay. Okay.
What is that? Yeah.
So, okay. See, guys, I just resized it and see, it is done in quite faster time. Okay. So now what I'm going to do is I'm going to do a select on this table here. Not this table, but the one that I just created. And meanwhile, it is fetching the data. I'm going to drop it from the other section. So say I have fired this query. It will take some time to get me the data, right? It is huge. And here I have dropped the table. It's successfully dropped. See, it's still running. What do you think will happen? I have dropped. This is no more there. Okay. If I go here and if I refresh, it's not there. If I go here, it's no more there. It's not there also here. Okay. But this query is running. What do you think will happen? See, it returned the results. So if you even in the middle of the query also, if you have dropped some table, Snowflake still shows you the data. But next time when you fire this query again, right, it will say it doesn't exist. So in the middle of the table, in the middle of the query, a select query, it will allow you to, it will give you the whole data back to you, even if you have dropped it. Okay. And now let's see what if you are updating or inserting something. Shit, for that I can use a smaller table. Shit, let me abort it. I can use a smaller example for smaller table for that. Let me go and resize it. I'm going to bring the size down. So is it right to say resize, guys? Is that the correct say terminology? I'm going to make it back to X small. So is it correct to say resize?
Scale up, right? For both increasing as well as decreasing.
No, scale up is increasing. Scale down is decreasing. But can I say resize?
Yeah,
So
we can, because the volume is less, right?
okay, so resize is applicable for both, whether you want to decrease or increase. Okay. But if you want to increase, it is called as scale up. And if you want to decrease, it's called as scale down. Okay. So I'm creating, you understood, like Arumuga?
Yes.
So I created this table with a smaller data set here. So what I'm going to do is I'm going to update through that transaction script. And in the middle of it, I'm going to drop. Let me create transaction name, transport, this. Okay. Let me hide it explicitly, guys, because sometimes I don't do the right selection and things get problematic. Now let me drop it. See, we dropped it. Oh, no. Sorry, I need to put some more data. It's coming very quickly. So we put some more data. I used 10. I should have used 100. Okay. Yeah. Now update and drop it. See, next time it's not updating. Okay, so it is the behavior of Snowflake. I mean, ultimately the integrity is maintained. Okay, so all the ACID properties are applied for. If anybody has worked on Spark, this is the problem with Spark. It doesn't follow the ACID properties. But of late in Azure, they have come up with the Delta Lake uh, storage. Okay, Spark doesn't have its own storage. It's just a computing tool. So they have come up with Delta Lake on top of Spark, which follows all, which makes Spark do all the ACID, which makes Spark follow all the ACID properties. Okay, but Snowflake inherits the, I mean, it makes sure that all the ACID properties are followed and to be qualified as a data warehouse. Okay. So that is what I wanted to show you today. It was an easy topic only, but it had to be shown. So you understand certain minute, differences. Okay. So some little last, what do you call, table functions and all that you can see for your this. For example, if you have logs, you can use show logs. Okay. You can abort a particular transaction. You can take the current transaction, pass it to it, and you can abort it. Or you can also pass a query ID and uh, fire this to cancel the query. Okay. For example, let me show you this quickly. I think I've dropped the table. And I'll this. Let me abort it. Okay, this is done. So I will select query. I'll go to the query ID here. Go back to this. See, it says query is terminated and it has cancelled. Okay, so you can terminate a particular query through this. You can abort a transaction through this. The update or that thing that inserting, updating that we're doing, right? You can abort it like this.
So if you don't have any transaction, right? If it's a normal not a transaction query, it's a normal query. It is taking long time.
Oh.
So still we can go and check the running query and get the what is the query?
Right. Yeah, from this query history, right? This history, you can go from this web UI also, and you can go through those views which I have explained to you during information schema and account usage schema, right? There were certain views there. Through that also you can see through status, which is so you will see a status here like running. The status here, right? This status is there, this first column. So you will have running. So you can go and see long running queries through your table functions, and you can, if you will get a query ID from there, and you can abort it. You can cancel it through that.
Yeah.
Okay. So that way you can do. Then you can cancel all the queries also for your session. You know how to take a session ID, right? Correct, guys? This is your session ID. You can kill all the queries in that. You can abort your whole session itself through this system $abort session. So, and if you want to see, I mean, this is not related to the topic we are doing, but if you want to see the parameters in the account, I think I've shown you this already. You have this, you can see all the parameters in your Snowflake. So we have this. That cache one, right? User use enabled cache, something was that. You remember the name of that? That cache property we used to disable and enable. Yeah, this one. Use cache as well. So we had disabled it at account level. It can be disabled at user level, session level. Remember? So these are all the parameters of a Snowflake, which you can see the properties.
Yeah, same way we have session level parameters. $B session.
In Oracle, yeah. Okay, yeah. So this is what asset properties I want to discuss today. And next week we are going to start with interesting topic where we will do the data loading, right? From some external source, we will do data loading into Snowflake. So yeah, so that is of course one of the most important topics in Snowflake. It's the heart of Snowflake.
So what external tool that you are going to use?
We will use S3 and local file systems. Okay.
S3. From S3 we will populate to Snowflake. That is what you mean to say, right?
Yes.
Okay.
And we will have some files on local system also, and from there also we will populate.
Through which Informatica?
No, direct.
Oh.
No tool required in between. I mean, of course, you can have a tool in between. I'm not saying that.
Direct tool, yeah. Okay.
Yeah, direct. And
look like SQL loader. That is what you mean to say, right?
SQL loader will load only for the local file system, right? If you have a file on the same server, then only it will load it. It cannot load from some other external files sitting on some other server. Okay. But yes, if you're trying to draw an analogy, yes, that way, yes.
Yeah.
For analogy point of view, yes. But the difference is that the file doesn't have to sit on the same server.
Okay.
Because see, what I will have files sitting in my local system here somewhere. Like for example, I have this employees file here, this one. This will go and get loaded into my Snowflake. Though I don't have to use an ETL in between or ETL tool in between. Okay, so this is on my local and it's going to get stored in my cloud because my Snowflake is in cloud, right?
Yeah, and as long as it is a simple load, we don't need any ETL tool, right? But if you have the source from multiple applications, multiple systems, and the format is file and the databases, heterogeneous connections and get and grouping, adding those things and all, we need it. This loading will not
happen. So like you said, if it's from say Oracle to Snowflake, right? Suppose this data I want to move, this employee data I want to move from here to Snowflake, then you need a ETL in between.
Yeah, it is plain load, plain data load.
Yeah. Or you can even have Python in between, whatever, up to you.
Yeah, Python in any transformation tool package. It can be a Python package. It can be Informatica package, whatever it may be, right?
Yes, whatever. Yeah. Whatever your organization project uses, up to you. Okay. I normally have worked a little bit on, I don't have much experience on the ETL tool side. Little bit I have experience on Matillion. But yes, I know how ETL, I have worked a little bit on it. So next week we are going to start this topic, and it is going to consume some time because we have a lot of scenarios in that and all that. Yeah. So yeah, lots of interesting topics coming up our way. So before we wrap up, any questions, guys? So please, over this week, please do the assignment for that micro partition. Okay. And once we finish this data load, right, hopefully in the next 2 classes, we should be able to complete it. If not, at maximum 3, then we will start that data workshop badge. I told you, right? There are 3 badges in Snowflake. So the first one, data warehousing badge, that we will start, and you guys need to do that over the week. And you will find it really helpful. Okay. Okay, guys. So we'll wrap up, and I'll see you.
Yeah. Do you have any idea on what DBT does? Why it is being used?
Yeah. So see, ETL, we have ETL that is for extracting, transformation, and loading, right? So DBT is on the transformation side. It only does the transformations. So it is a separate tool, and it is purely SQL based. Okay. So what you can do is you can load your data into Snowflake through S3 directly into Snowflake or through some ETL, whatever.
Any means. I have the data on the table.
Yeah. On that, you can do transformations through DBT. And you can create your dimensions and fact tables through those queries automatically.
Okay. Oh, okay.
Yeah. So I have also not worked on DBT, but I have just looked up what it means some months back.
Oh, it's like SQL tool, right?
Yeah. So it is doing so out of the ETL part, it is doing the T part.
Transformation part.
Yes.
Only transformation.
Only
the transformation can be only if you have the data inside my Snowflake. Yeah. Even a single procedure or package, Snowflake procedure and all can do the same transformation, whatever we do, right?
Yeah, that also you can do, but for that you don't need to know like those programming constructs like looping and all that. You can do it purely on SQL basis.
Oh,
yeah, and also for having version controlling, you can use DBT for that as well. Oh. Like how we have Git, right? We have Git, so you can have DBT doing that for you.
Okay.
Yeah.
Let me. Yeah. Okay. Thanks.
Okay, guys. So I'll see you next Monday. Next Saturday, and then we'll cover this data loading and all that. Okay, thank you guys, and sorry to get you guys so late. For India guys, it's too late, and you guys also, maybe having some other plans. So sorry for that. So yes, next time we'll start on time, a maximum 15-30 minutes late if possible. Okay, thank you so much, and have a great week ahead.
Thank you.
Yeah.